All right, welcome to The Explainer. You know when you throw a ball and just watch that perfect curved path it makes through the air? It looks so complex, but today we're going to break down the surprisingly simple secret behind it all. So, you're looking at this thing and it seems like one single complicated 2D motion, right? But here's the secret. What if it's not about solving one really hard problem, but instead solving two super easy ones? Okay, let's dig in. The entire field of projectile motion, and I mean the whole thing, is built on this one brilliant idea: breaking down complex motion into its simple individual parts. This is where it all clicks. The real key is to just stop seeing the curve for a second and start seeing the components that make it up. This is the breakthrough moment, really. If you get this, you're going to understand everything that follows. Okay, so what we're looking at here is a total shift in perspective. On the left, that's what we all see, right? One big, kind of confusing arc. But on the right, that's how a physicist sees it. Two simple, totally predictable motions happening at the exact same time. And look, our source material could not be clearer about this. It basically says, quote, "This is the most important part of the whole chapter. The whole chapter is based only on this." So yeah, it's a huge deal. You master this one concept of breaking a vector into its components, and the rest just falls into place. So how do we actually do this? Well, it's just a little bit of basic trigonometry. The horizontal part, Vx, you get that with cosine. And the vertical part, Vy, you get that with sine. But hey, don't get bogged down in the formulas right now. The big idea is that from this moment on, we can basically forget about the original diagonal throw and just focus on these two much simpler parts. So let's explore these two, well, let's call them independent worlds. They're happening at the exact same time, but they follow completely different rules. And what's crucial is that they don't interfere with each other at all. And this table just lays it all out perfectly. You've got the horizontal world on one side, simple, steady, nothing but constant speed. But then you have the vertical world, which is in this constant battle with gravity, always accelerating downwards. The most important takeaway here is that since they're independent, we get to analyze them completely separately. So because we can keep these two worlds separate in our minds, we can build this amazing toolkit to predict pretty much anything about an object's flight. Let's look at the key things we can now figure out. With just these three metrics, we can describe the entire path. Notice how the first two are all about the vertical y-axis. The sideways motion has absolutely no say in how long the object stays airborne. Now the range, that's where the two worlds finally come together. It's simply the constant horizontal speed multiplied by the total time it's in the air. And now that we have this framework, this way of thinking, all those famous formulas you see in textbooks, they stop being these random things you have to memorize. They become completely logical. They just make sense. See, you can see our two worlds right there in the math. Time and height only depend on the initial vertical velocity, and the range is just that constant horizontal velocity multiplied by the total time. It's a beautiful, logical system, not just a bunch of random equations to memorize. And with this framework, you can solve any standard problem. For example, here's a classic thought experiment. If you drop an object straight down and at the exact same time throw another one horizontally from the exact same height, which one lands first? Because their vertical motion is identical. Time in the air is a purely vertical problem. Since both start with zero initial vertical velocity and fall the same vertical distance, gravity pulls them down in the exact same amount of time. That horizontal speed has zero effect on how long it takes to hit the ground. This is the power of separating the two worlds. So, after all of this, what's the most important thing you should take away from this whole explainer? The formulas are just the result. The real tool, the real superpower here is the thinking process that gets you there in the first place. This is the fundamental problem-solving technique, not just in physics, but in almost any complex field. You see a big, scary problem, don't panic. Find the simple, independent components, solve those one by one, and then just put them back together. And that's the real lesson from the physics of a perfect throw. It teaches us a universal truth. Sometimes the hardest problems become simple once you learn how to look at them differently. Thanks for watching.